So today I wanted to talk to you about finding the areas of quadrilaterals. So here I have a few quadrilaterals. I have a trapezium, I have a rectangle, I have a kite, and I also have a parallelogram. Now, quite often you're given the equations and I want to show you why they work today. And to be honest, you don't even need to know the equations, you just need to know what's going on so you can work out the area rather than worrying about the algebra. So let's start with the easiest one. This rectangle, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 centimetres this way, and I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 centimetres this way. So that means that this length is 9 centimetres, this length is 10 centimetres, and they're perpendicular, so I need to check that. I can times those two together. It's really important that you look for perpendicular lengths, and I'll show you why later. So I have 9 centimetres going this way, 10 centimetres going this way. Just going to quickly scratch some on. So can you see that I have thickness of 1 centimetre going down this way 10 times, and I have 9 going this way. I'm really sorry, my straight line drawing is pretty poor, I have to say. Okay, and all in all, do you notice that now my area is made out of 1 centimetre squares? So that would be one here, another one here. Now if I have 10 going this way and 9 going this way, basically what I need to do is just do 9 times 10, which gives me 90, and that means I have 90 centimetres squared. Okay, so that's the first one. Measure the two perpendicular, which means right angle, two perpendicular lengths and times them, and that breaks it up into how many smaller squares there are within it. And this square is really important because it's called a unit square. And why it's called a unit square is because a unit means 1, so it has a side length of 1, and the area is 1 square unit. Okay, so the next one. Okay. I'm going to start with the trapezium because this is my favourite shape. You will have seen a half a plus b times by a height. And you probably think, I know how to do it, but I don't know why. I'm going to show you why. Okay, first you need to find your two parallel sides. So this is a parallel side and this is a parallel side. And notice I've drawn the angles to show that. Once you know the length, so this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 centimetres this way. And this one is going to be 17 plus 1, 2, 3, 4, 5, 6, 7. So I'm going to have 24 centimetres this way. Okay. What you do is you add both your parallel sides together and average them. Okay, so 17 plus 24 equals 41 centimetres in total. And I'm going to mean them. So the total of them is 41 and I'm going to divide by 2. So I get 41 divided by 2, which gives me 20.5 centimetres. Now, essentially, by meaning them, what you're doing is you're adding them together and dividing by 2, and that distance essentially gives you this distance here. So this distance from here to here would be 20.5 centimetres. Now, why that's so important is because if I cut down from that point and make a triangle, the amazing thing is, if I then spin that triangle around, it creates a rectangle. So by averaging the two parallel sides, it allows me to find the midpoint between the start of this triangular section and the end of this triangular section. And by cutting down from the midpoint, it allows me to create a triangle that fits exactly in my gap. So now I can model it on a rectangle. So I now know, if I just rub this out so I can work with it, that the average of the two sides is 20.5. So I know that this length here is 20.5. Now what I need to do to treat it like a rectangle is find out the perpendicular height to my base. So I'm going to count these: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I'd now do 20 times 13, which will be 200 plus, so I've done 20 times 10, which is 200, and 20 times 3, which is 60, so I get 260 centimetres squared. So my total rectangle would be 260 metres squared. Now notice that that's exactly the same area as my as my trapezium if I turned it down here. So this is why this makes sense. Essentially what you do is you take your two parallel sides, and they've called them A and B here, and you mean them. Once you've got the average side length of the two parallel sides, you then times by your height, because what we've done then is gone from our average side length and times it by its perpendicular length, which is height. This is exactly the same as this. All we've done is, rather than writing the half underneath our fraction to remind ourselves that we're meaning, they've just been a bit harsh and pulled it out. It's more beautiful, it's more grammatically correct to write it like this, but writing it like this makes it easy to remember and shows for understanding. So your two parallel lengths, A and B, so your two parallel sides, the ones at the same angle, are averaged. Once you've got your average, you then need to times by your height. So this is a parallelogram. It's not a rhombus because our sides are not all the same length. This side is 10.1 centimetres and this side is 15. So it's actually originally a rectangle that's been pushed over slightly. Now this is where the idea about perpendicular lengths really helps. You've got three lengths. They've given you both side lengths and the overall standing height. Don't work with this one because it's not perpendicular to the others. This one and this one are perpendicular to each other. By timesing them together, what we're essentially doing is cutting off this bit of triangle here, like so. And putting it over here. So notice now that we have 15 centimetres still and 9 centimetres this way, but now we've modelled it on a rectangle, so it's much easier to deal with. So the trick to parallelograms and rhombuses are: find your two perpendicular lengths and multiply those together, because what that does is it changes it from a parallelogram into a rectangle, and that's much easier to work with. Okay, so the next one is a kite. You can do it two ways. You can either measure this length and this length, so you're doing the full width. Oh, that's a bit long. Okay, and essentially by doing that, you create a rectangle around it. Now, if you notice, if I draw triangles in this, oh, it's slightly out, okay, then you'll notice that this triangle is identical to this triangle, and this triangle is identical to this triangle, and this triangle is identical to this triangle, and this triangle is identical to this one. Look at that. So all you do is you times your full width by your full height and then divide by 2, because essentially this is just another kite extra. The other way you can do it, oh, need a bit of spray. Beautiful. Okay, is to only measure half the width and the full height. Okay, by doing that, you're essentially just cutting this kite in half. Okay, and notice if I put it here and line it up to the rectangle that timesing these two would create, I'd have this, so one side of my kite, and then the other side, if I just cut it up to make it more obvious, will fit beautifully in the gap, she says. So you can either times your height by your width and then divide by 2, or you can divide your height by 2 and then times by your width. No, divide your width by 2 and then times your height. Sorry about that, said it the wrong way around. So this is a delta. This is the quadrilateral that everybody forgets. It's basically an arrowhead. Now, I think the easiest way to do this one is to use the same system as you would for the kite. If you half the width and times by the normal height, essentially what you're doing is just fitting part of your kite in a certain way to be able to make a whole rectangle. So if I do this, notice that my kite makes, my delta makes a perfect rectangle. Sorry, my cutting's pretty bad. My lack of scissors, trust me. My lack of ability to work scissors, not actually my lack of ability with maths. And that's it. So let's go through them really quickly to recap. Always find perpendicular lengths. Ignore any lengths that aren't perpendicular. So when you're given a rectangle or a square, times your height and your width together, because they're perpendicular. If you're given a trapezium, and it doesn't matter whether it's isosceles, isosceles means that you have two sides the same. If you average them, so your two parallel sides, if you average your two parallel sides, what that does is it gives you an average length which turns it into a rectangle. So you're going to do your two parallel sides, A plus B, divided by 2 to mean them, to find the average, and then times by your height. So this is base times height, whereas this is your average side, average of parallel sides times by height. And what that does is it moves this bit over here and this bit over here, and now we've got a beautiful rectangle that has exactly the same area as our trapezium. The next one is a kite. You can either times your full width by your height and then divide by 2 to get rid of the extra kite that you create, or you can divide your width by 2, so we only want this length, and times by your height, and what that does essentially is it puts these two pieces here and here. Okay. And that works exactly the same for a delta. And that's it really.